can see that when you take G double prime B over G prime B cubed, it is a linear A times B plus B. A is 4, B is negative 2. Square root transformation for the facade, again the same thing. Here, G double prime lambda over G prime lambda cube is negative 2. The next one, I don't know how familiar it is. I took the geometric. I know that in our paper we have written the result for a negative binomial, which is a convolution of geometry. So, but take the geometric. There, the transformation is not a very common one. Binomial Poisson, etc., quite popular. It is sine hyperbolic inverse mu, which is log of mu plus 1 plus mu squared to the power half. And here also, G double prime mu over G prime mu cube is minus 2. So if you have not seen it, you still see another a new distribution. The geometric or the negative binomial. Next slide. Example 4, the chi-square are given that you have the same result. The final thing is generalized hyperbolic secant. A strange distribution. You can see that. It looks like exponential theta y cosine theta divided by 2 cosine hyperbolic theta over 2. But turns out very nice. The mean is just tan of theta. The variance is, if you just differentiate, plus 6 squared theta, which is 1 plus tan squared theta, which is 6 squared theta, which is 1 plus squared. And here also, G double prime mu over G prime mu cube is minus. Next slide, please. So now use me. I've already said delta I. Mu just when you write mu is G inverse theta I minus delta I, because theta is G of mu I plus delta I, and you say transformation, so inverse is not a problem. They will not increase. Delta I have given you the formula because of the linearity, which is Di plus 2, Di mu I plus Di plus 4. Third, mu I you can write in terms of static weight and mu I. So basically what earlier what I was doing, all these calculations, I was mu I is G plus right. Although sometimes here shift information and still oh. I know the shift explicitly. I know the capital Di, I know my AI, I know my VI. So, if you can, the base estimate of G inverse theta I, given the data, the yi actually, call it mu I hat B, you can just correct mu I tilde B, mu I hat B, just a linear function. Just inversion of mu I hat B. And wrinkle base estimation, just estimate beta and A. If you go back to the original formula, beta and A actually, I wrote tau square earlier. A is same as tau square. You get mu I hat. So EB is again the mu I tilde AB, which we have used in the past, shifted by rotation scale. Next slide, please. Sample binomial, just a matter of illustrations. First wrote the mu I hat B, which is explicitly expressed in this way. This mu I tilde B, mu I tilde AB, we have done in our previous papers, but here we can easily get it by this equation solution. Same thing about Weston, same thing about other examples. 1, 2, 3. Let's move and try to get some more results. Next slide, please. That's an initial estimation. The assumptions are very standard. These are the assumptions which are made in the case of a failure model, and this time there is no exceptions except the nature of the function g. We had to add another thing. Let us condition the rank of an x is p. We are not in a large p small n situation, which is very common in these days. P is smaller than n. It is a full rank matrix. Then uniform asymptotic negligibility, that is condition some transpose and transpose x inverse xi is of order n inverse. Di is ordered ni inverse, of course, because to that side transformation or square root of 2. What condition is g is thrice differentiable. The other conditions are also from Fair-Harriot. This is the important thing. The moment you might think it is order m to the power minus half. That is not the case. It is of order m inverse. And then, of course, is order m inverse as well. And fourth moment is order m to the power minus 2. Letters are natural. Then we have provided an expression for the bias and the variance. Again, once you know the earlier results, G inverse theta is just a location and scale. Now, same thing, mi hat is an estimator of the mean square, so we have also get an estimator of the mean square as well, which we have given here. So the bias. Next slide, please. Bias and NC. Next slide. Interval estimation. It has been done by untransformed data in several papers which are listed, and some of them appeared in top journals of statistics. For unsigned transformed data, Cordero and Franco did it. And Cordero's version I'm taking about is, if you know sine inverse square root of p, if you want to estimate it, sine inverse square root of p, that is your theta, then what is p? P becomes sine square theta. That's why you are doing the adjustment. You are taking the adjustment theta I minus theta I and EB, and then take the quantiles, symptotic distribution, the quantiles of the symptotic distribution through the adjustment. The main thing is P is sine square theta. So that's why the interval estimation would be sine square theta I had EB adjusted with the percentiles. G1IA is the first moment of the Fair-Harriot. And Q, and the Q things for the percentiles of the bootstrap approximation of the distributions. But they did it, I mean, Cordero and others, because the tacit assumption is mu I is J inverse which we have. It's like consider dg inverse gy plus ZL plus minus G alpha by 2, a number of different situations. There is a dipole, should be theta I hat EB plus something ui hat F, and again there is a plus missing two cases in the first bullet, the two pluses missing, and ui hat F is the uncertainty measure, whatever it is. It's bootstrap, you can use liver expansion, whatever it is with that condition. Under the regularity conditions for large n, you can show that in our framework. This theorem is mu I belonging to that interval, whatever that II hat is 1 minus alpha plus order n to the power minus 3 by 2. And n is big. N is summation ni, I from 1 to n. That is big. The notation G inverse denotes application function G inverse to the lower points, either one, whichever. Next slide, please. Let's just mention, I think we are sitting close to the time. So just briefly mention, and I think I will be done. G by I also we can write as sine inverse 2yi minus 1. The reason is sine inverse y to the power half has a linear relationship with sine inverse 2i minus 1. Nice exercise, and it is a very well known. So original scale data was randomly generated from an only pi. The direct estimator was wij, but theta is just to be considered a simple intercept order. We assume that pi is just that relation, reflecting the implicit relationship between pi and theta. In this simulation study, I think we used sine inverse 2i minus 1. 40% individuals were assigned weights, 1. 20% was assigned 2, and 40% as 3. And scenarios with n either 15 or 50, n is 10 or 100. So even if n is 50, one of the areas exceeds the n by twice that amount. Some of the areas. A is 0.006, setting the replication number as 5. Slide, please. So we evaluated the performance of empirical based estimators with the direct estimation, natural big transformation. Now there are several ways of estimating that model varies. You can use REML, you can use adjusted REML. REML is the most common one which was used, but there is a very fine paper by Ilsameri. By the way, Ilsameri is the same as Hiroshi. She used to be called Ilsameri before her marriage. Now she is Hiroshi. Okay, same person. And Martha Lahiri, one of my famous students, devoted his whole life with small area. Very famous guy. And in the estimator of A under the assumption theta is G mu y, which is not quite right, etc. All those things. And so there are several things. And now, next slide. I think I will try to get it there. Next slide. If you can see it, the last two columns are ours. Not the last two, direct estimate, EBYL and EBRE are surely one empirical based estimates. The one we have proposed, we evaluated actually some in a simulation, quote unquote, truth, how to see the relative bias, the relative MSE, and so on. The next one. And we can see that we are having not always an improvement, but with the relative bias, as you can see, and also sometimes with the relative variance. But sometimes we do have a kind of improvement. It is still not a very clear picture. We are working on it all the way. Let us skip transferences and go to the final thing. Final remarks. Final remarks. So transformation of variables is often necessary to bring the transformations closer to normality, and variance stabilizing transformations have the added feature of producing non-sampling. The present article introduced a location and scale shift of the customary black transform estimates of the parameters of interest. Here only you have considered area level models because you can see that we have taken the summary. A natural extension to go to peak level model, spatial model, time series model. There is a host of things which can be done. Thank you very much for your attention. I'll be happy to answer questions. Thank you. Any questions?
Hello.
Yes.
The floor is now open for questions. We can take maybe a few quick questions, right, Satish? Only one or two. Only one question.
Because I don't want to interfere with that.
Yeah. That's okay. Next question. Moreover, it's a very, very interesting talk. Lots and lots of open problems. So such a wonderful everyone. What types of transformation?
That's the total.
Why is the total? So when I take the sign of this quantity, the sign is restricted between 0 and 1.
Is binary, it is only sine inverse 0, sine inverse 1.
By definition of sign, correct? Something you're looking at.
Correct. But normality still holds.
Of course, it is normality will still hold.
The picture gets a close resemblance to symmetry. That's the thing. It is not exactly normal. It's not.
Yeah, I'm sure.
But it is a close approximation to normal, as saying this restrict, whereas normal is negative infinity to cosine.
Other cases get the it doesn't impose any constant estimation.
Same thing with Poisson, 0 to infinity. Negative.
0 to 1. So maybe a constraint estimation there give you possibly less bias or should be, I don't know. Because you already have this
closer to normality, not exact normality.
Thank you for the clarification. Okay, Satish, I think let us thank our esteemed speaker. It was wonderful having him with us today. Thank you, Maulana, again personally and also on behalf of the committee. Okay. Satish, over to you. Satish? Big hand. Yeah, very interesting talk, Professor Malay. And we a lot of are enjoying your talk. I hope that there are a lot in this too. And Professor, I hope between there is a call line that sits by just fixed the last minute remarks. I hope since we have late the timing, whether I hope no questions further we can allow for the time being. Let us move to the next session. Let us also be thankful to Professor Ashish Gupta for chairing this session and making it a vibrant and active session. And Professor Malay, we are always grateful to you for your support and your presence here in this platform and your promise to come over here to Trivandrum next time.
If I get a sufficient advance notice, I will try to work around it.
Yeah. And you please come over here.
Only in the winter, only in the winter. Keep it
tax and let us talk regarding the details.
So that's all we're looking at 2026.
Sure. So. Students, please give thanks to the once again as a formal thanks to our chair and please we'll move to the next session and I invite Professor Malay to chair. Please, students, please.
Satish, I'm going to use my present now and move on to my slides, okay?
Yeah, that's better. But let me tell you Ashish first. Which is our directional data, as Barry Arnold once said, and I believe it. Is our directional data guru. His contribution to directional data is phenomenal. Phenomenal. I've learned a lot from his work concerning directional data. And I'm very glad that he's presenting something here, and I'm looking forward to his talk. So, Ashish, the floor is yours. The screen is yours.
Yeah. Yes. Desktop. Yeah,
so I have shared my screen.
Okay. Yeah. Now we can see the slides, one page. Yeah. Now the first page. Okay, Professor.
So in the problem, I need to see because it's a little bit more time. Okay. So I'll be directly showing you. Right. Okay. So it's such a big honor for me to have you here and share this session. So it's always been an extreme learning experience and always an inspiration to us. So thank you again for taking your time to share this session. So what I'm going to talk about today, was sort of a well-known problem, which will be of course a little different. So I try to unify some of the procedures, and maybe with some of these young students or researchers, you'll get to see most powerful inputs. Okay, so those kind of situations arise, and those are also difficult to prove. Number one. Number two, the parameter that we're looking at, one of the parameters at least, is the speed parameter, the change point itself. So the maximum likelihood estimator usual properties that we see from the math channel, they do not hold you. That is speed parameter 3. Professor Malay Ghosh has done seminal work. sometimes we are trying to do is to provide you with a unified approach, optimality approach. And this can be used for the optimality base. It's not the optimality base. We're trying to use this for the expedient as a non-expedient one. And we're trying to mitigate the other basically hurdles that are there. Real life examples we can present and just need to propose that. So this is a part of this work is jointly done with Professor Sandro Blaha, which is currently RBI Chair Professor Indian Statistical Institute, Kolkata. He is my former PhD student. He is also very well known, a data analyst, one of the top 20 data analysts in India. He came out from magazine, cover page. He's with IIMT in Switzerland. So we are going to be doing this. And this paper is right now is in the hot press, right? Is in the press, quick volume, which has been edited by Professor Andrew Becker. The environmental statistics is a finger volume, and paper is available. Hopefully, it is. I try to hyperlink it. Change is in terms of the parameters. So there are many situations we may know the initial value of the parameter. We may also suspect the change value of the parameter. But the main point is we do not know where the change point is. We can have all the three parameter sets the initial parameter value, the change parameter value, along with the change point itself, all are. So we have to determine these and do particularly this approach. Okay. So I'll start right away
അത് വേറെ എണ്ണ ഉണ്ടെന്ന് തോന്നുന്നു. കീ എടുത്തായിരുന്നു. കീ എടുത്തായിരുന്നു. സോറി.
കസ്റ്ററിലാണോ?
So, delta is like but remember to do an angle. Whenever I'm talking about natural angle,
ഇങ്ങോട്ട് കയറി കിടക്കുന്നതെല്ലാം പഠിച്ച് പുറത്താകത്തില്ല.
and of course, translate minus minus. There are major positions. So one of his work has been in the very nice, in the sense that it was a very simple exposition. We could do the major procedure, but it came one problem. Actually, the general applies to the things. I think that was one of the very first difference. And those of the interested can have a look at it. As I said, it's a fully Bayesian approach, relying on only on uniform. And so it will be very, I think, interesting for you to look at. So, this particular hypothesis that I will test, and the approach that we are going to look at will be the final section when all the parameters will be shown. Will be realization of the was done by Professor Hall and then by McPherson, and we'll be using that. And thanks to the work of President by Professor we'll see that the result there and sometimes tedious, and that's where those results that become useful that will show the good. Now, should I include insurance? Please, that will be insured. So let's say change point mean for the mean direction. They were all known, but you gamma, not delta, as you say, they're all known. You want to know delta, either way, they're all known. But R is a because my influence includes the half time. Die when it's you over two. And you see why it's not coming up. One southwest as a within the strength. You can see through that this will be going at the distance. That's why we need the two down square. These are the practices. Just in the beginning, we're looking at the test and hard so for testing it's not against the one. If R is known, you will find out that it's on the human now by here R equal to 1 is incoming kind of die by the alpha and second case by the cosine, the second case by the sine. And then let's denote by V0 start T as the time reverse to Brownian motion that we have on 01 with a gift and the R with a regular like test and what's the R is that the program is and then we can do it. But of course, R is
ചായ കുടിക്കാൻ മറന്നു
after the next part, location, state, standardized, testing.
പിന്നെ ഇടയ്ക്കുള്ള സ്റ്റുഡൻസിന് അവസരം കിട്ടിയില്ല
Of the two of zero and
വീണ്ടും അതെ അത്രയും
because the discrimination is always a big problem and most of the people have to reverse this and so on that way. Of course,
ചോദ്യം ചോദിക്കാൻ പ്ലാൻ ചെയ്യാൻ കേട്ടിട്ട് ചെറിയ ചെറിയ സംശയം പോലെ ചോദിച്ചാൽ മതി പിള്ളേരല്ലേ പിള്ളേർ എന്ത് ചോദിച്ചാലും അത് നല്ല സന്തോഷം
some of the times we cancel, the report that you are there that are not ready for the one that you want to get. That's where you have consent short term. Remember, R is a discrete parameter 1, 2, n minus 1. And then it is the minimum for which delta is minimum. You find delta equal delta R hat. The rules. What is simple rule? What is simple rule? Now tell me, how do I get my 3 of 1? So now to have after the null has objectives, we are the AID, which you find that the expectation new, you find that the fair, the function naturally is fair. Don't you remember? That is y minus, and then we have this converted into equal, if we go on to follow this then on the class 3-1. The time reverse without a position in the interval 0-1. This is
അവിടെ അവിടുത്തെ വർക്ക്ഷോപ്പിന് എന്ത് പറയണമെന്ന് ഞാൻ ഇതുവരെ തീരുമാനിച്ചിട്ടില്ല അത് കോൺഫറൻസിന്റെ അയച്ചു കൊടുത്തത് നല്ലത് അവിടുത്തെ വർക്ക്ഷോപ്പിൽ
price of the national share code what we do, so we can have it. The cutoff point can be approximated using the algorithm that the probability is the proof of the people saw greater than equal to alpha, then equal to can be approximated by the probability of a standard normal distribution of the upper T and the normal. I think the graphic result sales was analysis, I think this is a very useful result. It might have been used somewhere else, but we have not seen this. And this will be something that can use for last sample. And in modern with big filter, I think we can look forward to having the moderate sample size. We will see if that so an alternative to this thing, which is acceptable assembly distribution given by the non-norms, the triple norms, and the non-scaling to be. This is not uncommon to have a dump slogan. After that means you need a large sample size to make a result out of it. So if you have a good big data in terms of size, then you can quickly and second that's the word out. Again, the similar system. And then define on this that's the criteria. You the students convert to probability by the expression of minus e to the minus e point. So, but the proof or the divisions and application of letters and darling and set off. So again, we have feasible, preventable cutoff points that can be used in our practice, I think, quite conveniently. If you have quite large size, and if you have already have size, then you can use time reverse down. That kind of using the approximation there. This one is the last that not much. So that's the particular one.
ചേട്ടന് പരീക്ഷ ചുമ്മാതെങ്കിലും ഇത് പോകുന്നുണ്ടെങ്കിൽ മോള് ചിലപ്പോ ബസ്സിൽ പോകേണ്ടി വരും. ഇവിടെ നടന്നുകൂടാ. ഇറങ്ങുവാണെങ്കിൽ കുഴപ്പമില്ല. മാമൻ ഇതെല്ലാം വെച്ചോണ്ട് കൂടെ പോകും. ചേട്ടന്റെ ആവശ്യമുള്ളതുകൊണ്ട് അവന് എന്തെങ്കിലും കാണാൻ നെറ്റ്വർക്ക് പ്രശ്നമൊക്കെ വന്നാൽ മാനേജ് ചെയ്തോളെ. എല്ലാവരോടും പറഞ്ഞോളെ കയറി മാനേജ് ചെയ്യണം. നെറ്റ്വർക്ക് ഇഷ്യൂ എന്നൊക്കെ പറഞ്ഞിട്ട് താങ്ക്സ് പറഞ്ഞ് വീണ്ടും കണ്ടിന്യൂ ചെയ്ത് അങ്ങനെ പോയിക്കോളാം. പിന്നെ ഇത് റെക്കോർഡ് ചെയ്യുന്ന കാര്യം അതുപോലെ ചെയ്യാനുള്ളത് ഇല്ലാത്ത സമയത്ത് കിട്ടിയിട്ട് പോകാം. എവിടെ അല്ല നമുക്ക് കൊണ്ടുപോകും. നാളെ ലാപ്ടോപ്പ് ഉണ്ട്. ആ ലാപ്ടോപ്പിൽ ചെയ്താൽ മതി. അങ്ങനെയാണെങ്കിൽ കുഴപ്പമില്ല. ഓഫ് ചെയ്യാൻ പറഞ്ഞാൽ മതി. ചെന്നോടൻ പറഞ്ഞിട്ട് ദാറ്റ്സ് ഫൈൻ. ഒരു പ്ലാറ്റ്ഫോം അങ്ങനെ പോട്ടെ. അടുത്ത ദിവസം മുതലുള്ളത് മറ്റൊരു പറഞ്ഞ് നാളെ ഉള്ളത്. നാളെ ഒരു ദിവസം 5 എടുത്തു. അപ്പൊ കുട്ടികളെയും കയറ്റി ഇരുന്ന് അഡ്ജസ്റ്റ് ചെയ്താൽ പോലെ അങ്ങോട്ട് ഇങ്ങോട്ട് മാറി. രണ്ട് ഡിവൈസുള്ള രണ്ടെണ്ണം ഉപയോഗിക്കാൻ പറയാം. ഫോണോ ലാപ്പോ ഉണ്ടെങ്കിൽ
So we want the locally most powerful, unbiased, guarantee and master and we also guarantee power, local level of our network. Okay, so I could type and again take the maximum of this. Have process and then but the serving share, we can take the concept central limit share and the concept get time to work down portion and we can again apply
ഇത് ഓവർടേക്ക് ചെയ്തോ. ഇത് പെട്ടെന്ന് പോവുകയൊക്കെ ചെയ്തു പറ്റുള്ളൂ.
very quick for this. The microfunction, the smoothness, which can see parameters
നമ്മുടെ ഓടിച്ചിരിക്കുന്ന ടാഗിൻ സാർ
expression. Maybe then comes the next. As I mentioned earlier, C1 R part will cancel out, but with R under equal to cancel out one will remain in then part one part, which gives rise to the SN part 1. You have to go But the fact is computable, but by regards to that, that does not have exactly so I think it's exactly for us because very difficult to get even a cadet exactly what you feel for the United. Whereas for our Olympic test minister, was a very effective. So now let's go into the main frame straight point. Speed of the whole system that are the MAD. Now there will be three types of MAD. There will be one first part where the point the R is the take point. That's one up. And one I think not we keep conditions are not estimate the initial direction. You're not also retaining the direction. So this would have made towards the
മറ്റേ മലയഘോഷേ എന്തോ ഏത് സമയത്ത് പറ്റത്തില്ലെന്നാ പറഞ്ഞേ?
ഇവിടുത്തെ സമ്മർ അവിടുത്തെ അവരുടെ സമ്മർ പറ്റില്ല അവരുടെ വിന്റർ ടൈമിലാണ്
വിന്റർ അൺവാണ്ടഡ്
including like the derivative, where there's derivative, there's a compound, there's exponential, there's delta. So now in all our calculation, we go through the normalized full vector, the not usual full vector, but is normalized by one of us. Which then the asymptotic theory, as you can see, really that is useful to give you the asymptotic formally detected. So that is why the normalization. So we don't need by cap S. Whenever you have the cap S, remember that it is the small s divided by the scale. It's the normalized full vector. The matrix V that refers to two information. This is obtained by dividing the information matrix I by the sample size. The expectation that taken as an H naught is that the element is computable, and we can look at the I view. Looking at this forms the Asian that you're looking at, and the Asian are unicorn that is getting from the V. You see here all divided by the quantity for the quality taking effect. So this is the main matrix that we will and for example, three drop partial that we're looking at orthogonal classification, drop value and orthogonal. And the best at the set of derivative are the equal to. With respect to delta, we've got part result for the delta is the delta. That's the first part. Other one it involves with the delta.
സെമിനാർ ഹാളിൽ തന്നെ ലാപ്പ് വെക്കണമെന്നില്ല, ഇവരുടെ റൂമിൽ വെച്ചാലും മതി,
That is delta.
റെക്കോർഡ് ചെയ്യാൻ പറ്റും.
That is the delta. Going to be the transport.
നാളെ വർക്കിംഗ് ഡേ ആയതുകൊണ്ട് കുഴപ്പമില്ല.
So we are here, we are ready. Okay, that is like our the movement of the statistics of the based on the PR, which is the first target, the square over the PR target again. So the set target is where it is estimated what I took. Like the many of the decision after H naught, the effective are what I saw. So after H naught, everything things are quite nice and smooth. We have this that was what I the one the distribution estimate the mean direction is estimated by the sample distribution to the enemy. So we like kappa is the from R1. It was the function the I naught is our special question, but it is available and we can go and then it's this is nice and comfortable. So similarly, we still have the data is estimated effective for information. And it's complete with the effective part. I present that data by study. So the straightforward computation, we take the exact data and start data. And very simple. That is what is a data. Now we can the role of our organization. So then it is quantity over here, which is again it's confused.
അവന്റെ ബാഗ് ലാപ്പ് എടുത്തോണ്ട് അവിടെ നിന്ന് പെട്ടെന്ന് ഓൺ ചെയ്തു
ലഞ്ച് ബാഗ് ഇതിൽ വെക്കാനോ അതോ
Also, that company, we can learn something following form that I have mentioned. So, you first, to let I have a device, let I have a something that then you have, then, technology, third, you can find the so, in our name, things that done, that, the security, is given identity, so, why, but the treatment are, listed, maximum price that everything to get that out. Okay, so what is our constraint? The problem is vulnerability to that it's kind of that is normal and significant parameter or the thing that is the value most the parameter no given that let's see kind of the so given that parameter depends in time to become a week sometimes that's the way that very much that is power job internet you so when the bus will be the big one then I have to also get that you and that you know to get the reason and that you that you can all in the clear the time because they been done we made it school day right the time 10 minutes of you can make it you can change right now one night one the application telling about in the hospital and the other side one effort thanks that's fine you can open about it maybe come up with a certain and you can yeah that's fine whatever so, people give up, but if they come and take the food there, but the guy around my example food, the number of people that I have to take food, then you find out, then about that, because the leader became, about the doctor, the work, and then I will know, then what to do, about hotels, keep them, the burning that, and this is why the people is wrong, and from the food, all but you business people and do not have pain by power. You second work is not very difficult. And especially with the environment, which is one of the environment the fifteen, everything has better. Kingdom, extra, return, compared to that, finger thing. Their money, trading their own future, let's be, thank you, evidence. Thanks for the speaking. Over to you, Mark. Sorry, it is going to be working. Well, Chairman, because of the strong idea here. That's a great thing to show that I'm negotiating. So I'm actually, in the Ghana, on the script, we did some good results on probability national rise, which you mentioned. And one of the examples was the special office. Was quite interesting. There was another one of man which could he served us thinking the first one $7 prize that one is. So that's what you could have. Yeah, that's exactly right. Yeah, that calculations are not. But that's cool. So,
Any other question? If not, let's thank our speaker.
Thank you very much for the feeling. Thank you, Madam.
This very important. So let's consider your intensive test of the management. We should also have a discussion. Also that so that the officer for signing rental income for the user challenges. Also press my heart percentage for the participant. Still process of the advertising. It session 10 for your kind participation. Yeah, by concluding this session, I think to action our life once again. Closer and